Let's start the derivation of electrostatic potential energy. Say a plus q source charge is kept over here, and there are 2 points. We have to find out the electrostatic potential energy between 2 point A and B. This is point A and this is point B, and we have to find out the electrostatic potential energy between these 2 points. And we know that if somehow or other we find out the work done to bring that test charge from Q0, the test charge Q0 from A to B, and if somehow or other we calculate that work done WAB, that is work done to bring Q0 from A to B, then it is equal to, as we have already defined, it is equal to the difference in the potential energy between these 2 points, that is UB minus UA. So if somehow or other we calculate this work done, then we can easily find out the difference in the potential energy between point A and point B. So let's find out. Say this is the source charge plus Q, and it is due to this an electric field is generated in this direction. Electric field is generated in this direction, and due to this electric field, this charge Q0 experience a force Fe, that is the electrostatic force or electric force due to this charge, due to the electric field which is produced by this charge. And there is another point B which is RB distance away, and point A is RA distance away. So these thing it is given, and now we have to find out the work done. So suppose if I have to move this charge in this direction, and suppose a very small displacement dr, then I have to do some work because I have to go against the electrostatic force, because electrostatic force try to move this charge in this direction, and I have to keep it in this direction. So I have to apply some external force which must be equal to the Fe, so that there should not be any kind of kinetic energy, any kind of acceleration should not be produced. It must be as much equal to Fe as possible. So the small amount of work done to bring this test charge to the very small displacement dr is given by dw is equal to Fe dot dr, and as you can see here, the angle between these 2 points is 180 degree, so it becomes Fe dr cos 180, and which comes out to be minus Fe into dr, because cos 80, the value of cos 80 is equal to minus 1. So, and we know that the value of Fe is equal to minus Q naught E. So this value if I put here, so this become, the expression become like this, and we know that E is equal to KQ upon R square. So if I put over here the value of E in this expression, so this expression become minus Q naught into KQ by R square. So this is the small amount of work done to bring test charge Q naught from A to small displacement dr, and that is into dr is also here. So this is the small amount of work done. So the whole work done W, if we want to find out, then we have to integrate this dW from A to B. So this become if we integrate this from A to B, then we can easily find out the total amount of work done, because we know that this is equal to minus Q naught K Q upon R square into dr. So if we integrate it, so the integration of this with sign with limit A to B gave us, since Q naught K Q upon R square, all these things, this one is constant, so we can keep it out here. K Q Q naught upon R square R square, we have to keep it inside because it is a variable. So A to B 1 upon R square into dr, and that is equal to minus K Q Q naught and 1 upon R square, that is R to the power minus 2 into dr, which is when we integrate it, it will give minus R to the power minus 1, and with limit A to B. So this is the integration, and if we put the values A and B over here, then we can find out easily what will be the expression. So the final expression look like this: K Q Q naught, and this is minus, because Q naught is minus here, and it become minus 1 upon RB plus 1 upon RA. If we put the values, the limit, the final limit and the initial limit, then the value look like this. So this is the expression, this is the total work, which can be written as WAB. Now if we multiply this KQ Q naught to this equation, then the final expression become like this. You can find out the final expression also. It should be equal to this expression. This is the expression. Here it look like this. So if you can see here the WAB, the value of WAB is KQQ naught minus KQQ naught, is like this, and minus 1 upon RB plus 1 upon RA. It is the same expression over here. You can see 1 upon RA with positive sign and minus 1 upon RB with negative sign. So if we multiply negative sign inside the bracket, then we get the final expression WAB is equal to KQ naught 1 upon RB minus 1 upon RA. So this is the final expression. So this is equal to the difference in the potential energy. So we can write like this: UB minus UA, that is the potential energy between the 2 point A and B. UB minus UA is given by WAB, and it is given by this expression KQ Q naught 1 upon RB minus 1 upon RA. So this is the derivation of electrostatic potential energy between 2 point A and B.